So in this problem, we have a 3 by 3 matrix, and rather than making you use a determinant to find the eigenvalues, I've just told you that the eigenvalues of B are 1 and -2. Then I ask you to find a basis for the eigenspace of B corresponding to each eigenvalue. And that means we're going to solve B minus lambda I times x equals 0 for each lambda. That's just what we do. We solve B minus lambda I times x equals 0 for each value of lambda. So we start with lambda equals 1. So I'm trying to solve B minus I times x equals 0. That's what we're trying to solve. So we're going to use an augmented matrix. So I'm going to have 1 minus 1, -3, 3. Next column will be 3, -5 minus 1, and 3. And then the third column will be 3, -3, and then 1 minus 1. I'm going to remind us that we're dealing with an augmented matrix for a homogeneous equation. This augmented matrix will be equal to 0, -3, 3, and then 3, -6, 3, and then 3, -3, 0, and then zeros. So let's find the augmented matrix, or sorry, the reduced echelon form of this augmented matrix. So I usually write an arrow like this and say, oof. Okay, so I'm going to get a 1, 0, 0. So I'll move the first row up, and then I start doing row operations. So I'm going to do the row operations just thinking about it. I'm not going to use my calculator because I'm really good at row operations. Let me just start performing row operations in my mind. Let's see. Don't ignore the calculator tapping. That's not me using a calculator. That's just totally what it sounds like when I think about row operations. I know it sounds like I'm using a calculator, but I'm totally not. So here I'm still thinking, and get rid of all this stuff. I mean, think about other stuff. So 0, 3, 3, 0, -3, -6, -3, 0, 3, 3, 0, 0. Okay. Oh, dang, my calculator is visible. So the reduced echelon form, we end up with 1, 0, 0, 0, 1, 0, -1, 1, 0, 0, 0, 0. So we get x3, or x1 is equal to x3, x2 is equal to minus x3, and x3 is free. So the solution, the vector solution, will be x3 times 1, -1, 1. So a basis for the eigenspace of B corresponding to 1, lambda equals 1, is 1, -1, 1. For shorthand, we might just say in braces, the vector 1, -1, 1, and then just say 4 lambda equals 1. That might be a good solution instead of writing this whole thing. But we're not really writing, we're typing, so I'm not really concerned. And if you left off the lambda equals part, since lambda, you'd have to enter in the equation editor. If you just said corresponding to 1 is then this matrix, then that would be fine. So we've got to do this for the other eigenvalue. So we'll have to go and grab lambda equals -2. And so that's going to be the matrix B minus or plus 2i times x equals 0. So I'm going to solve this with an augmented matrix, as we always do. And so it's going to be 1 plus 2, and then negative 3, 3. Then next column will be 3, and then negative 5 plus 2, and then 3. And the third column will be 3, negative 3, and 1 plus 2. I'm going to remind us that we're solving a homogeneous equation. So I'm going to write an augmented matrix. And then the first column is going to be 3, negative 3, 3. Second column will be 3, negative 3, 3. And the third column will be 3, negative 3, 3. And the last column will be zeros because homogeneous equation. Now in this case, I can actually fake the solving in my head. I don't have to fake solving in my head. We can see that if I just add the first row to the second row, it wipes out the second row. And if I subtract the third row from the first row, I can get zeros there. So the reduced row echelon form will just be 1, 0, 0, 1, 0, 0, 1, 0, 0, 0, 0, 0. So that one I actually don't need a calculator for. I shouldn't have needed a calculator for the previous one, but you know, it's early and I haven't finished my coffee yet. So oops, this is not equal to anything. This is where it stops. So here we got x1 is equal to minus x2 minus x3. x2 is free, and x3 is free. So a basis for the eigenspace, let's see. So our solution in parametric vector form is x2 times negative 1, 1, 0 plus x3 times negative 1, 0, 1. So just write that in parametric vector form. Now for shorthand, we could say that the basis for the eigenspace corresponding for B, basis for the eigenspace of B corresponding to lambda equals negative 2 is negative 1, 1, 0, comma, negative 1, 0, 1. And then we'll just write next to it for lambda equals negative 2. That's going to be our shorthand, so we don't have to write that whole sentence. In this case, the question on the quiz or test or final exam is going to be explicit in what we're looking for. And so we can shorthand some things. You don't have to write a whole sentence when you're asking a pointed question. How much does this cost? $20. You don't have to write a whole sentence. The cost of this object is $20. Any questions? Comments? Snide remarks? Great. Let's pause the video here and then we'll talk about some important facts about eigenvalues and eigenvectors.